So we're two students on this university for quite some years now.
So we want to energize the debate around energy. So, for example, why with advanced technology nowadays isn't the energy problem solved yet? What's going on? Also, we want to increase the engagement of university students here in Eindhoven and ultimately centralize the knowledge. We are not alone in this. We gathered a group of students and I proudly introduce to you Team Energy.
Ladies and gentlemen, I would like to welcome you also after the students did with their enthusiastic ways to try to solve the world. Very good. Go ahead and do it. My name is Wim van der Zande and I'm an experimental physicist at the University of Nijmegen. Why is an IPCC report that consists out of, this is only the physical science basis, the first of 3 volumes will be generated this year, and this volume consists of 2,216 pages. So I wonder who all can read it, which only describes the physical science basis, and it has beautiful science inside. But why is it not weight enough? How much more extremely likely do we need to convince the society? And maybe it's another psychology. Mankind has just problems with handling dangers. And certainly if a danger seems to be beyond the horizon and dealing with your children and grandchildren. And it is my pleasure now to invite the first speaker, Peter Kuipers-Munneke.
All right, so one of the topics that are going to be covered today on these Energy Days is the cryosphere. And the cryosphere is basically everything that is the water in the solid phase, which is ice. I will mainly focus on land ice in this presentation. And if you look at all these glaciers, there are an estimated more than 100,000 glaciers on our globe. And if you look at their length, we see that more than 90% of them have been retreating over the past century or century and a half. Now, those are glaciers, and there are more than 100,000 of them. And you have probably walked on one or seen one in real life. But there is 2 super glaciers on Earth, which are the ice sheets. There is a big ice sheet on Antarctica, which is by far the largest ice sheet that we have nowadays. And there is another ice sheet, which is Greenland, which is situated on Greenland. And, well, if we put everything in perspective, all these 100,000 glaciers that we had, which have been contributing about 8 centimeters since the middle of the 19th century, but this is really dwarfed by the contributions of Greenland, which contains almost 3 million cubic kilometers of ice, which it would be enough to raise the sea level by more than 7 meters. And then there is the really big giant, which is the Antarctic ice sheet, containing more than 25 million cubic kilometers of ice, which, if all melted, would contribute more than 55 meters of sea level rise. So these are, at the moment, sleeping giants that we better not wake up.
Caroline Katzman works at the KNMI, at the Climate Research and Seismology Division, or the Global Climate Division.
What can happen in a changing climate, and what role does the ocean play? One important example that I'm sure Henk is going to talk about too is abrupt changes in the thermohaline circulation. So you may have seen this film almost 10 years ago now. It's called The Day After Tomorrow. That basically showed this idea in a movie and ended up having an ice age and then ice sheets over New York. That part is not true. That's not going to happen. It's not going to get that cold in the greenhouse gas scenario. But the whole idea of thermohaline circulation shutting down, that was in that movie. All right, sea level rise. First again, the observations. This is also from the latest IPCC report. What you're looking at is 300 years of sea level changes, global mean sea level changes, well, say 35 to 80 centimeters, global mean sea level rise. Sea level rise locally or regionally differs a lot from the global mean. This is the anomaly pattern in percentages, so the deviation from the global mean projection we have. And this one has really waken up the United States, certainly in combination with Hurricane Sandy, and said, well, you get a hurricane and we even get 25% more sea level rise than the rest of the world. Maybe we should start thinking about this. So I'd like to end with a quote of one of my favorite oceanographers, Walter Monk, who said that the oceans, they are the principal reservoir for the storage of CO2, of heat, and of ignorance. And I think that still holds.
Thank you very much. It's a pleasure to introduce Henk Brinkhuis, who is a General Director of NIOS,
what is very important here in my talk throughout, you saw it in the episode as well, that you really have to make a mental exercise that we're talking about climate now, and climate is the average of the weather for 30 years. And I am used to talking to a very young audience, you know, students. They are like 18, right, 19, 20. So you guys, you haven't seen climate in a stable fashion. Now to some facts. Facts is how did CO2 develop in the atmosphere, in this case over the past 50 years or so. Another fact comes from the ice cores. And what you see here is that this is now, we are now at the time scale of the past 20,000 years. This is 1850, and we are already at 400. All right? So the Earth has not seen this, at least for 650,000 years. Stronger, the Earth has not seen this in 25 million years. Okay? And this is where we have to learn from the past. On geological timescales, the relationship with CO2 concentration and temperature on Earth is a one-to-one. You erase CO2, you will get temperature response. We are not able, however, to look into will it happen like over 5 years, over 10 years, over 20. But we can tell you that within like 250 years to 500 years, this is a one-to-one relationship. So we are doing this, and it's our world. You know, 60%, 70% of the world's global population lives at sea, or is dependent of sea. So the sea level, temperature. If you want to know more, we especially developed a high school program, because we found that on the Dutch high schools, this climate science is not being told whatsoever. Thank you.
There is no reasonable doubt anymore. So it is towards mitigation, adaptation, and being also not inward looking to our country alone, and maybe realizing that we have to give up a certain percentage of wealth, but we get back for something which we can call sustainability for the future generations. And I think with this, I would like to thank the three speakers who gave their excellent introductions. Thank the audience, and we have a break.